Okay, vectors, this is the big subject, so I may have to break this up into 2 videos, but I'm going to try and teach it the best way that I can. What a vector is, I think most people understand. I think you get that it's an arrow. It's like an arrow. You can say that it's got some direction, maybe like an angle, 35 degrees north, and then you can say that it's got a magnitude, which can be either 4 meters or 20 miles per hour, or any numerical value like that. What I think a lot of people aren't getting right away is the way that we have to break these things into the x and the y components, and I just kind of want to clean up the way that it's taught, and hopefully I can help some people. Okay, so we are taught to make this big T-chart and say, okay, what's the x, what's the y? Oh, look at me using the line tool. What's in the x, what's in the y, break down the components. They give us all kinds of sine and cosine, and give us numbers, ratios, radicals, all that crap. I'm going to try and make this easier. Let's name this. Let's say that this is called, let's call this vector Bob. And you can do that. You can actually name vectors some really weird things, especially if you get into different kinds of physics, but we'll just call this vector Bob. I wouldn't do this on a test, but it works. We'll say that vector Bob, which should actually have an arrow over it, but we're not going to bother doing that. Vector Bob, we're going to say is, I don't know, how about 20, it doesn't even matter the units. The math does not change based on what units they are, so I'm not even going to put that in there. And let's say that it's at an angle of, let's make it 30 for the sake of ease. Okay. And that's from the horizontal, kind of obvious, but I figured I'd put it in there. Okay, so what I'm going to have you do is I'm going to teach you a kind of new notation. In vector coordinates, one way that you can express a vector is you can say the x value, and that's times I, and I is kind of like a unit vector. I is kind of like 1 in this x direction, plus whatever the y value is, times j, where j is kind of like 1 unit upwards. I and j don't have real numerical values. You can't divide by them. You don't treat them like variables. And actually, they're not really variables. They actually have these little hats on them in actual vector notation, but I'm not going to bother with that because I can't use that on a keyboard. But this is the x component. That's just what this means, and this is the y component. So we could say that vector Bob, if you remember, is, well, how can we express this? Well, let's say, okay, what is the, what is the x component? I'm going to put all of this in brackets, because we are going to need to multiply it by something in a second. Maybe you can guess what. I'm going to use t in place of theta, because it's just faster. So what is the x component? How far out is this? If you kind of shine a light straight down, how long is this shadow? Well, that's what the cosine of t is, cosine of theta. Maybe I'll do that. Cosine of theta. And since that's in the x direction, we're doing that I, because that's our kind of, it's like our units almost. I kind of stands for units in the x direction, if you will. And then plus, well, what's the height at this point? If the radius was 1, remember, the height would just be that sine of theta. And then times j, which we said was just kind of like the units in the y direction. J is 1 small unit upwards in the y direction. So that's nice. That should work, except these are really actually pretty small values, because this is only if this line was only 1 unit long. because it's the unit circle, if the radius of the circle is only 1. But here the radius of that circle, if we were to kind of draw a circle, not like that, if we were to kind of draw a circle, the radius of this circle, oh crap, that's not even close. The radius of this circle, I kind of give up, is 20. So what we just need to do is actually multiply this whole thing times 20. And now we have our x and y components in a pretty simple equation. Now we have that our vector bob equals, well, let's distribute the 20. We get 20 times cosine of t in the I units, which is kind of like individual units in the x direction, plus 20 times sine of t, j units, right? J, it could be meters, it could be miles per hour, it can be newtons, it can be pounds, it can be teddy bears, it can be pretty much anything. This is a unit, think of it as. This is a unit. I is 1 unit in the x direction, j is 1 unit in the y direction. So now say we've got another vector. Maybe this is a larger vector at an angle of, say, 15. Oh yeah, line tool only. And say that it's got, maybe it's 40. Maybe that's its length. Well, we'll kind of do the same thing, right? Let's call this Alex. We'll say that Alex equals, well, we can kind of just, right, we know that it's 40, right, the length of it, the radius of that circle, how big the circle is, times our cosine of t I units, right? It's the kind of like the length of this shadow, right? If there's a sun right up here casting a shadow, it's this length. That's the cosine. And the units is just those I units, those little individual units in the x direction, plus a sine, the height, theta, in j units. J is... Yeah? I will.
Right now.
Okay. Okay. See what I do for you. Okay. So, where was I? Oh yeah. J, that's units in the y direction. So, I mean, you know how to multiply this out. It's equal to 40 cosine of t in units in the x direction, that's the I, plus 40 sine of t units in the j direction. Well, now it's actually kind of convenient if, say, we wanted to add Bob and Alex, because Bob plus Alex, we have these two bits right here. Here, let me draw little boxes around them. We have, these are in 1 units, and then these are in completely different units. So if we just add them together, all we have to do is add their parts. So this actually becomes kind of simple, because now Bob plus Alex equals, I'm going to say it's simple, but it's actually kind of ugly, but you'll see. It equals, I'm going to switch to red. Ah, crap, can't do that. Oh well. Let's go back to blue. Bob plus Alex equals, well, first we're going to add these two together, so it's 20 cosine t plus 40 cosine, oh, I'm sorry. I misled you. This is not t right here. These are not the same t's. I'm sorry. Now let's make that f. And now let's make that, instead of t there, pretend that the whole time I wrote k. So sine of k in those places. This is a k. This is a k. Sorry. Let's try that again. So when we add them together, we get that that's equal to 20 times cosine of t, right? This one is t. Plus 40 times cosine of k. This k, remember that's k, I'm sorry. And that's in units in the I direction. Plus 20 sine of t. Plus 40 sine of k. And whatever those add up to, those are the number of units in that j direction, in the y direction. And now, well, it's actually pretty easy to add these because we know what t and k are, right? So really all it is doing, it's just plugging this into a calculator. What's cosine of t, or cosine of, let's say, the 30 degrees, times 20, plus whatever cosine of k is, times 40. You add those together, and that's how many units in the x direction is. That's how many I there are. I's units in the x direction. And then here, again, you just plug this stuff into a calculator, add it together, and you get the number of units in the j direction, the height of that resultant vector. And after that, like I explained before, say you get that the resultant vector is right, I don't know, here. Well then, you should remember that they're going to ask you to... Okay, so the I direction part right here, that's what this is. That's what this is. Right here. The j direction part right here, that's what this is, right? Because that's just what lines up there. That's just the kind of horizontal shadow and the vertical shadow there. That's what these are. So then you can use the Pythagorean theorem, square both sides, add them together, take the square root to get the length of this resultant vector. It's not 40, that was the other thing. The length of this resultant vector. And then you use that thing that I was telling you, how the inverse tan, you put in a slope. So in this case you're going to put in whatever you get for this yellow expression over whatever you get for that green expression, and that's going to be equal to the angle. Be careful because that might give you an angle like, say, negative 105. You just have to remember that negative 105, okay, so that's over here somewhere. So if you subtract, I mean, that's just kind of figuring out what the angle actually is, say, north of west. I mean, you should be able to do that. But hopefully that makes some sense. It's a kind of different way of looking at it, but learn that, number one, because you'll need it for later on math courses, but number two, because hopefully it should make computations a lot easier, and I'll show you why in some later example problems and just as I'm teaching later concepts. Next video I'm going to be teaching some two-dimensional projectile motion. I'll see you then.